Hey guys, here we are again graphing. But today, instead of graphing cubic functions, we're graphing their inverse, cube roots. Now, a cube root graph looks very similar to a cubic graph. Remember, a cubic graph goes up really quick and down really quick. Now, a cube root graph goes out to the right really quick and out to the left really quick. They are inverse of each other. Now, with that, there's a reason why. Because this one, we were multiplying everything by itself, so it's jumping up really quick. But this one, you'll notice here that we are we're reducing everything really quickly because we are kind of like dividing by itself 3 times. It's not really a good way of putting it, but you get the idea. We start with a big number like -8, and it spits out -2. And you'll notice these are even reversed. Okay? With my parent points for a cubic graph was -2, -1, 0, 1, 2. And this time, these got switched. So, very similar graphs. And once again, all we're doing is we're just going to be shifting it around left, right, up, and down, and go from there. Now, our transformations still happen the same way. To have a vertical stretch or compress, we're talking about A. To have a horizontal stretch or compress, that's B. That's inside the parentheses. This time not the parentheses, the cube root is inside the cube root. A vertical reflection, a horizontal reflection. Well, a vertical reflection would be a -A. Horizontal reflection would be a -B. A horizontal shift, remember, that's still my H. And H is still a liar. So if it's inside the cube root with X, it's still lying to us. And last one, vertical shift is K, and that controls my up and down. So these are going to work the same way that they have been working for everything else. Okay? So, like for instance, a horizontal shift, 3 units left, and a vertical shift, 6 units down. Well, horizontal shift, 3 units left, that means that my H is going to be -3. And a vertical shift, down 6 units, that means my K is going to be -6. So my equation for this one, we just got to plug those in. It doesn't say anything about A or B. So we're just going to go f of x equals A is 1, B is 1. So we're just going to start off with the cube root of x. Then we have my H. So we're minusing my H. So inside my equation, it's a liar. So we're actually going to go +3 on the inside. And then on the end, we're going to have a -6 for my K. All right, let's take a look at number 3. Number 3 says reflect vertically. So very front and center, right off the bat. Reflect vertically. That means that I'm going to have a -A. Then we're going to have a horizontal stretch by a factor of 2. So a horizontal stretch by a factor of 2 means that my B, remember, B is backwards. So if we're stretching horizontally by a factor of 2, that actually means that my B is going to be 1/2. It's flipped. Then we have a vertical shrink by 1/3. Okay. Now, A is not backwards. So if it's a vertical shrink, that means that my A is actually going to be 1/3. And then last but not least, we have a vertical shift down 5. So that means my H is going to be -5. So here we go. We can go f of x, or y if you prefer, equals, then my A, I know it's going to be negative, I know it's going to be 1/3. So it's going to be -1/3 times the cube root of my B. And my B is 1/2 times x. There is no H. H is just 0. So then lastly, my K. Oh, I don't know why I wrote H there. That's my K. K, there we go. So my K is -5, so that's on the end, -5. So we're going to have f of x equals -1/3 times the cube root of 1/2 x minus 5. Okay, number 4. We have a vertical compressed by a factor of 1/2. So once again, vertical compressed by a factor of 1/2. My A is going to be 1/2. Second, we're going to have a shift 3 units to the right. So my H is 3. And then we're going to go 2 units up. So my k is 2. So my equation is going to be y equals, my a is 1/2 times the cube root of x minus 3 plus 2. Okay, our last one here, number 5. So number 5 says, reflect horizontally, stretch vertically by a factor of 3. So if I reflect horizontally, that's going to give me a negative b. And if I stretch vertically by a factor of 3, that's going to be my a is going to be 3. So we can write my equation for this one. We can go f of x equals not just a is 3. So we're going to go 3 times the cube root of negative x. We have to have a negative in there. All right, guys, there you go. That's how we find those equations and how we write those out. Excellent. Let's turn the page and let's graph a couple, okay? So this was the parent functions for my original one, but for our new one, we're going to flip it. So this is for x cubed, but we're going to flip it. We're going to have my x and y instead are going to be -8, -1, 0, 1, and 8, and -2, -1, 0, 1, and 2. But we still affect them the same way. And so we're going to find our points by manipulating them with a, b, h, and k. And remember, you can use your graphing calculator or Desmos to help you out with these. Okay? Remember to find your y-intercepts. We let x be 0 to find my x-intercept. We let y be 0. And your center is whatever h and k is. All right? Okay, so let's take a look at number 6. So number 6, we don't have an a, we don't have a b, so those are just going to be 1. My h is going to be the opposite of that. It's going to be -4. And my k is going to be -2. My parent function for this one, well, we're talking about cube roots today, right? So my parent function for today is the cube root of x. Now let's talk about transformations on this first guy. My transformations are going to be, well, we're going to go, if h is -4, we're going to go to the left 4. And if k is -2, we're going to go down 2. So we're going to have a point to the left 4, down 2. We're going to have our point there. That's going to be my vertex, or my center in this case. Remember, our center is whatever h and k are. And so it's going to be -4, -2, right there. Then we can stop and we can try to find some points. We're going to remember 1 over b plus h. For my x is 1 over b, x plus h, and a times y plus k. Well, the great news is I don't have a b, I don't have an a, so we're just going to manipulate with h and k. So we're going to take each one of my points in my parent points. Goodness. Each one of my points in my parent points right here, and we're going to add h to each one. So let's see what happens if I do that. So if I take -8 and I add -4, that's going to take me to -12. -1, and if I add 4, that's going to take me to -5. 0 and I add -4, that's going to take me to -4. That makes sense. That's my center. 1 minus 4 is -3, and 8 minus 4 is -4. My points over here for my k value. We're going to take that, we're going to add it to each one of my y values here. So we're going to go -2 plus -2, we're going to go have -4. -1 plus -2 is -3. 0 plus -2 is -2. 1 plus -2 is -1. And then 2 plus -2 is 0. So that's going to help me put my points. We're going to start here at my center, and we're going to put these points in here. So I'm going to have a point at -4, -2. That's my center. Then we're going to have a point at -3, -1. That makes sense. -3, -1 right there. Then we're going to have a point at negative, sorry, this shouldn't be negative 4, should it? Of course not. That should be negative 2. Oh, man. Messing up, aren't I? Or where did I mess up before? Let's see. I messed up somewhere. So it should be negative 5, negative 3, and then we take my 8, minus 4 from it. It should be a positive 4. I'm so sorry. Okay. So then my next point is going to be at positive 1, 2, 3, 4, 0. So you can see how my graph is going to go out really fast that direction, out to the right. Then my other graph is going to go the other way. We're going to have a point at negative 1, 2, 3, 4, 5, down 3, right there at negative 5, negative 3. And then we're going to have a point at negative 12, negative 4, so like out there. And so you can see how my graph goes really fast out to the right, really fast out to the left. It is definitely a cube root graph. Okay, my y-intercept. Well, we need to solve for my y-intercept on this one. My y-intercept is whenever my x is 0. So we can go, okay, y equals the cube root of, and instead of having an x there, we're going to go 0 plus 4 minus 2. Well, 0 plus 4 is 4, and then the cube root of 4 I can't actually find, can I? Well, we can use our calculator. Remember to do cube root, we go math 4, and so we're going to find the cube root of 4, and that's going to be 1.58. Now, with that, we're going to minus 2 to that, so we're going to minus 2 there, and my answer is going to be 0.4125. We're just going to round it up to negative 0.41. So my y-intercept is going to be at 0 and then negative 0.41. Now, that makes sense. Okay, I intersected a little bit high. It should have intersected it like right there. But you get the idea, right? There's my y-intercept. Now, my x-intercept, we already know what my x-intercept is. It's right here. Okay, it's going to be positive 4 and 0. We already put that on there. So my x-intercept is going to be at 4, 0. And then lastly, my domain and my range. The great thing about these graphs, just like cubic functions, your domain and range are going to be all real numbers, negative infinity to positive infinity. So we have that, all real numbers, negative infinity to positive infinity. All right, so that's kind of a quick breakdown. Let's turn the page and let's try another. Remember, if you get lost on some of the points, plug it into Desmos, plug it into your calculator, okay, and that'll help you out with it. All right, on this one, we have f of x equals negative 3 times the cube root of x plus 1. Now, in this problem, my a is negative 3. My b is still just 1. My h is negative 1, because remember it's the opposite, and my k is 0. My parent function is y equals the cube root of x, and we have a lot of transformations. My first transformation is I'm going to have a vertical reflection because of that negative out in front. Second transformation is I'm going to have a vertical stretch by 3. And last but not least, because my h is negative 1, we're going to go to the left 1. Now that's going to really help out my center. Remember, our center is h and k. So if we're going to go to the left 1, we're not going up and down at all. My center is just going to be at negative 1, 0, i.e. whatever my h and k are. Okay? Then we're just going to find some points to go with it. We have our points at negative 1, 0. It's going to have this weird vertical stretch. You'll see it. You'll know what I'm talking about here. And so whenever I do this, my normal one, remember, our normal parent function is negative 8, negative 1, 0, 1, 8, and negative 1, negative 1, 0, 1, 2. Now, our new one is going to be, remember, it's going to be 1 over b times x plus h, and it's going to be a y plus k. Now, there is no b and there is no k, so we're just going to go all of my x values plus my h and my a times my y. So start here with negative 8. Negative 8 plus my h, which is negative 1, is negative 9. Negative 1 plus my h is negative 2. 0 plus my h is negative 1, 0, and 7. So there are my x's. Now my y's. There is no k to add to it, so we're just going to go a times my y, and my a is negative 3. So this is going to be a negative graph. So we're going to go negative 3 times each one of these. So negative 3 times negative 2 is a positive 6. Negative 1 times negative 3 is a positive 3. 0 is 0. 1 is negative 3. And 2 is negative 6. So you can see my points here that I'm going to graph. We already have a point at our center of negative 1, 0 right there. But let's graph everything else. We're going to have a point at negative 2 all the way up to 3. We're going to have a point at negative 9 all the way up to 1, 2, 3, 4, 5, 6 up there. We're going to have a point at 0, negative 3. And we're going to have a point at over 1, 2, 3, 4, 5, 6, 7 down 1, 2, 3, 4, 5, 6. Now, take a look at this graph. You can tell that it definitely had this vertical shift, where my graph normally is like this, and it shifted up pretty extremely. Okay. Now, obviously that caused some stretching in my graph, and that's all because of that a being 3. It caused that vertical stretch. And so you can also notice that, look, we went over 1, up, 1, 2, 3. So you can kind of think about it as your slope a little bit, just like what we talked about in our first graphing lesson. Now my y-intercept is going to be, when x is 0, so it's going to be at 0, negative 3. And my x-intercept's when y is 0, so it's going to be at negative 1, 0. No fancy math on this problem. My domain is x equals all real numbers. My range is y equals all real numbers, or negative infinity to positive infinity. All right. Last but not least, let's write some equations from a graph. So number 8, we're going to write the equation for this one. So it is a positive graph. Remember, our last graph was negative. It opened in that downward direction. This one is a positive graph, so we don't have to worry about a reflection or anything. And let's find our center. So our center is going to be right there at over 2, down 3. So we're going to go to the right 2. We're going to go down 3. So that tells me some stuff, right? My h is 2. My k is negative 3. Now, notice something else. It stretches. It goes up 3 over 1, down 3 to the left 1. So that means that we're going to have a vertical stretch by 3. And that also means that my a is equal to 3. So now I can write my equation. My equation is going to be f of x equals a, which is 3, times the cube root of x minus my h. So x minus 2, it's opposite in there. And then on the end we have my k of minus 3. All right, our last one here, number 9. Number 9, we have some transformations going on here. My first transformation is that we're going to go to the right 1 and down 2 to end up right there, right? So right 1, down 2. And that tells me what h and k is, right? That means my h is going to be 1, my k is going to be negative 2. Next up, Notice, it's opening downwards. So that means we're going to have a vertical reflection or a negative A. So a vertical reflection or a negative A. And last but not least, look here. It's going to go down 2 over 1, down 2 over 1. So that means we're going to have a vertical stretch by 2. And so that's just going to tell me that my A is equal to negative 2. It's negative because of the reflection, and it's 2 because of the stretch. So last but not least, my final equation is going to be y equals negative 2 is my A times the cube root of x minus my h, which is 1, plus my k, which is negative 2. And so there we have our equation. Okay, guys, as always, hope this video was of help to you. Let me know if you have any questions. This is all about graphing and solving. All right, have a great rest of your day, guys.